Hello everyone. Today we are going to work on our next lecture and we are going to work with inequalities. So let's talk a little bit about inequalities. What are inequalities? Well, as everyone knows, probably two numbers, like we're dealing with numbers in math, can be either equal to each other. For example, 5 equals 5, right? Or can be not equal to each other. For example, if you compare numbers 5 and 6, we know that 6 is greater than 5, right? And if we compare numbers 5 and 6 this way, we are going to know that 6 is greater than 5 still, but the sign of inequality is going to turn around. So that's what we are going to work today with inequalities. Well, you probably kind of know that inequalities are not always comparing certain numbers, but sometimes they're trying to find how variable is compared to a number. For example, we are going to write down inequality 5 is less than x. So x are going to be all possible numbers which fit into this inequality. So how do we kind of describe these numbers? There are two ways to do this. One is a number line notation. Number line notation is going to be something like this. We draw number line, put 0 somewhere. I'm going to put also 5, not very important like how far, because we are going to just have two numbers, 0 and 5 here. I'm going to make 5 an empty circle. And now all numbers which are greater than 5 are going to fit. For example, if I have number 6 over here is going to fit, number 7 is going to fit, all numbers between 6 and 7, and actually any number over here is going to fit. I'm going to shade the interval and number line and show that all numbers starting with 5 but not including it are going to fit into our inequality. So this is a way to give the answer as a number line. What if we want to give the answer as interval notation? We're going to write down x belongs. Belongs means that can be any number from the interval. And interval is going to start from the left side of the interval. Left side of the interval is 5. We are not including 5 because like numbers supposed to be exactly greater than 5. And on the right side, we are going to have infinity because we actually don't have the greatest number, which is greater than 5. Any bigger number can be always overgone by the next bigger number. So that's a simple inequality and that's how we solve it. Now let's try to solve something a little bit more complicated. More complicated, I mean, we're going to deal with linear inequalities. What are linear inequalities? Well, they look like linear equations. For example, 4x plus 2 greater or equal than 5. Well, looks like I like number 5, right? What is the difference between this inequality and the inequality we had before? Well, first, we have also equal sign. Equal sign means that if x will give you, when you substitute here, exactly 5, it's still going to work for us. Second difference, instead of just x like we had it before, we are going to have x multiplied by 4 and added 2. This is a linear equation, and that's why we call inequality linear. The power of x is equal to 1 here. How do we solve it? We solve inequalities exactly the same way we solve equations. So only one thing to remember is that when you multiply equation by a negative number, nothing happens to equation because it's equal, right? I mean, not nothing happens, but you can do it without consequences to the equation. For inequality, we have to change the sign to the opposite, but I'm going to talk about this a little bit later. For right now, let's try to solve this one. First, I'm going to subtract 2 from both sides of inequality, like I usually do with equation. So here 2 is going to cancel, and I'm going to get 4x, keeping the sign of inequality. 5 minus 2 is going to give me 3. Now I'm going to divide. Well, usually we say we multiply by 1 over 4, but I would just say that I divide my inequality by 4 on both sides. You're supposed to use the same number of both sides. And we are going to have x on the left and 3 over 4 on the right. So if I ask you to graph your answer on number line, what are you going to do? You're going to graph somewhere 3 over 4, right? Then, because it equals, we are going to make this circle dark because we are going to include it, and then make x greater than 3 over 4. Greater means over here, to the right from 3 over 4. Sorry, my computer is making up like strange additions. If I ask you to write it down, the answer in interval notation, you're going to write down x belongs, and over here 3/4. We always start writing down our interval from the very left point of the interval, and then infinity. Infinity always is using parentheses, never square brackets. Square bracket shows that we actually can use 3/4. If you substitute it here, you are going to get exactly 5, because 3/4 multiplied by 4 is 3, and 3 plus 2 is 5. So that's our answer. Let me talk 1 second about multiplication by -1. I'm going to return to my inequality on the left and kind of just change my color. So we see inequality 5 greater, less than 6, right? 5 less than 6. I'm going to talk about this inequality. If I multiply this inequality by -1 on both sides, I'm going to get -5 and -6. We do know that -5 is located somewhere here, and -6 is located to the left from -5, right? And we do know that -5 is going to be greater, so numerically is smaller, but on number line, it's sitting on the right of number than -6. So we are going to write down an inequality sign like this. You see? So basically, that's going to be our rule. If you multiply your inequality by any negative number, not just -1, then you are going to change the sign of inequality on opposite. If your inequality had equal sign is going to just stay with it. Okay? Okay. So let's kind of move to some other type of inequality. That's another linear type of inequality is double inequality. Sorry. Kind of, where is my eraser? I think I can just. So what is double inequality? Double inequality, it's actually like you have two inequalities at the same time, has something like this. Inequality like this, 2 less or equal than 2x plus 5 and less than 8 is called double inequality because you have kind of two inequalities working together. Any double inequality can be represented as two separate inequalities. I'm going to show this once, but normally if inequality looks like this, we are not going to do this. So this inequality, it's actually two inequalities, 2 less or equal than 2x plus 5 and 2x plus 5 less than 8. Usually we are not going to split inequality in two, but if you like to do this, you're always welcome. If you look at inequality sign, you see that here we have less or equal, and here we just have exactly less. So that's kind of different sides are going to have different coloring for the ending points. Now, how do we solve this inequality? Well, same way we are solving equation, just we are applying now same operations to all three parts of inequality. For example, I'm going to start with subtracting 5 from all three sides. My goal is isolate x. So I'm going to subtract 5 from all three parts of inequality. 2 minus 5 less or equal 2x plus 5 minus 5 and less than 8 minus 5. Now 2 minus 5 is -3, right? Over here we have 2x because these two are canceling each other. And over here we have also 8 minus 5 is also 3. Wow, very nice. Now, to isolate x, we'll need to get rid of 2, right? How do we do this? We divide by 2. I'm going to divide all three parts of my inequality by 2. And I'm going to get -3/2 here, less or equal, and x, and then 3/2. Well, accidentally, I got symmetrical numbers on the left and on the right. Not necessarily going to happen every time. You can have different numbers. Now I'm going to use number line. So I'm going to start with -3/2, -3/2, and then graph +3/2. +3/2 is going to be to the right of -3/2 because it's greater, right? Now I see that over here I have equal sign between -3/2 and x. So I'm going to actually make it a dark circle. Now my axes are between this number and this. So I'm going to shade the region between -3/2 and 3/2. And the final touch, write down final answer in interval notation, square brackets, and we are going to start with the very left side of inequality, -3/2. And then 3/2 on the right and parentheses, because this bubble is not colored. Well, that's going to be the final answer. Okay, good. So we know how to solve one inequality, we know how to solve double inequalities. Let's move on to next topic, which is called nonlinear inequalities. Sorry, guys. Sometimes. Okay. So what are nonlinear inequalities? Well, nonlinear inequalities means that instead of linear equation, something like 2x plus 3, you are going to have something nonlinear. What can be nonlinear? Basically anything. Anything means that it can be, for example, quadratic, trinomial, it can be a more complicated polynomial. I'm going to use a really complicated expression to show you like the kind of interesting example of nonlinear inequality, but can be more complicated. Anything but linear is called nonlinear. So I'm going to start with inequality x plus 3, x minus 1, x minus 2 greater or equal than 0. How do I know that this inequality is nonlinear? If I multiply all these three parentheses, the power of my x is going to be equal to what? Well, x multiplied by x is a square, and multiplied by one more x is a cube. So that's going to be the x cubed. So it's cubic polynomial, and it's already factored for us, which is very convenient. I'm going to show a method of solving nonlinear inequalities when they are factored. So what kind of method we are going to use? Well, we are going to explain this method a little bit later. For right now, just trust me. We are going to use interval checkpoints. So what are you going to do, guys? First, you will need to solve each factor and find out what is x, which is turning each factor into 0. For example, this factor is turned into 0 when x is equal to -3, right? Here, x equals 1. And over here, x equals 2. Those are zeros of this polynomial. Now, you draw a number line and label all zeros of the polynomial on this number line. So I'm going to label -3 here, and then 1 here, and then 2 here. It's not necessary to make it in scale, but if you feel better when you make it in scale, you do this. Okay, so, well, I'm probably going to color all these empty circles because I do have equal sign into something like dark circles. Now, guys, what I see that there are like 3 possible points where this expression turns into 0. Well, besides this point, somewhere between the points, expression is not equal to 0, right? Not equal to 0 means that it's either positive number like -2 or +2, or negative number like -2. Well, what also we know that, for example, if I choose a point somewhere between 1 and 2, for example, 1.5, my expression is going to have a certain sign at this point. In neighborhood points, like a little bit to the left, a little bit to the right, the sign is not going to change, because to go, for example, from plus to minus, you will need to cross the line, right? And the crossing the line can happen only at 3 points, this, and this, -3, 1, and 2. So everywhere else, my expression is not going to change the sign. So if one point, for example, between 1 and 2 is positive, all the points are going to be positive. Just because to make a negative point, it must go through 0. And we don't have any zeros here, means that it does not cross actually x-axis between 1 and 2. What I'm going to do, guys, the method is called like a test points. I'm going to test 1 point for each interval. How many intervals we have? 1 interval from -infinity to -3, 2 from -3 to 1, interval number 3 from 1 to 2, and 2 to infinity. Well, how I'm going to do it? I'm going to write down test points here and choose 1 point for each interval. Which point to choose? You actually pick it up. I'm going to pick up x equals -4 for my first interval over here, because -4 sits somewhere here. I'm going to change my color. Somewhere here is going to be -4. What I'm going to do next, I'm going to plug -4 into my expression. So I have -4 plus 3, which is -1, right? Then -4 minus 1, -5, right? And -4 minus 2, -6. If I multiply these three numbers, I'm going to get a negative number, which is going to be -30, right? You actually don't even need to know whether a number is like 30 or not. You just need to know the sign of the number. And you know, if you have three minuses, eventually that's going to be the minus, the total number. So I'm going to put over here minus. I'm going to check other test points like x equals, well, any point between -3 and 1, the good point is 0, right? And easy to check. If I plug it in everywhere, I'm going to get something like 3 multiplied by -1 multiplied by -2, and my total answer is going to be 6. But I just need to know that that's plus. And now one more point over here. So I was checking 0 here. 1 point between 1 and 2. Well, I'm going to check 1.5. Again, you choose any point between 1 and 2, which you think is convenient. For 1.5, what I'm going to do, guys, I'm not going to calculate the number, actually. I'm just going to imagine. Okay, 1.5 plus 3. Is it positive or negative? Positive. I'm going to just write down plus. 1.5 minus 1. Still positive. 1.5 is greater than -1. So I'm going to write down one more plus. And 1.5 minus 2. Yeah, 1.5 is less than 2, so it's going to give me a minus. So if I multiply all three of them, the total result is a minus. So I'm going to put minus here. And that's a good way to do it too, because sometimes it's just difficult to multiply many numbers. The last interval I have left is from 2 to infinity. So I'm going to choose point, I don't know, let's choose 3. Or you can choose actually 1000. That's still going to work here. And I'm going to do pluses and minuses again. So for my 3 plus 3 is plus, right? That's positive number. 3 minus 1, it's actually 2, it's still plus. And 3 minus 2 is 1, it's plus again. So the final answer is plus. I'm going to put plus here. Now, guys, I have all these pluses and minuses for intervals, right? I'm going to circle them, but it's not necessary actually. Which of these 4 intervals I'll need to choose as solution? Well, let's look at inequality sign. We need intervals which are going to make this side greater than 0, right? Means positive. That means this interval is going to work for us. And this interval is going to work for us. In interval notation, you're going to write down x belongs. Here, both points are included, so -3 and 1. Then, because you're unifying the second interval over here, you're going to put u, unify, and write down the second interval from 2 to infinity, and 2 will be included. Okay, very good. So I think we can move to next type of inequality, which is called absolute value inequality. Okay, let me scroll this up, write down absolute value inequality. Absolute value inequality. Well, what is absolute value inequality? Well, you remember what is absolute value. Absolute value, it's a kind of a distance from your number to 0. Let me kind of explain it first. Maybe you forgot it already. That's 0. For example, if you have 5 here, the distance is 5 units, right? So we're going to have absolute value of 5 equals 5. If you have over here -5, the distance is still 5 units. Both, right? So absolute value of -5 is still equals 5. For us, the very simple way to remember this that both numbers, positives and negatives, are going to kind of be positives after you apply absolute value. It's just like absolute value is just kind of eliminating the sign of the number. Okay, so there are 2 possible absolute value inequalities we can have. Inequality number one is going to look like this. X absolute value less than C. C is going to be a number, or something like 5 or 2 or whatever. Okay. What is going to be a solution of this inequality? Well, let me write down this inequality in like opponent, let's say. So what means that absolute value of x less, I'm going to use an example, absolute value of x less than 5. Well, it can be open as two inequalities. First, x less than 5, right? All x's less than 5 are going to work here. Greater than, equal than 0. Well, just imagine that you check numbers from 0 to 5. Gonna work here, right? What other x's are going to work here? Well, negative x's are going to work here. For example, -1, if you put absolute value is 1, less than 5. I'm going to write down what negative numbers are going to work here. -5, x, and less than 0. So all numbers from 0 to -5 are going to work here also. Well, if you look at these two inequalities, they're going to kind of cover the interval. If this is 0, if this is 5, if this is -5, circles, we're going to get all the numbers between -5 and 5. Well, actually, this inequality means that distance from number x is less than 5 units. So any number for which distance from 0 to number x over here is less than 5 units, this distance is going to be fitted. And they're going to kind of sit like 5 units away from 0. This direction and this direction. Maximum, they can be less. We are going to unify this inequality into double inequality. We're going to write down x less than 5 and greater than -5. It's going to make our kind of solution a little bit easier. But if you don't like it, you can always unify it as two inequalities, represent it as two inequalities, -5 less than x and x less than 5. I'm going to put here and because x must satisfy both of them. For example, if x is just less than 5, for example, -7, which is less than 5, but does not fit this inequality. -7 is obviously not greater than -5. It's not going to work for us, right? So number -7 sits over here outside. So it's supposed to be both inequalities at the same time. Let me show you an example of solving inequality of this type. For example, 2x plus 1 is less than 5. So how do we solve this inequality? We are going to write down 2x plus 1 less than 5 greater than -5, like I did over here. And then just kind of solve it like we were solving before double inequalities. So I'm going to subtract 1 from both sides, -1, -1, -1. So it's -6 less than 2x less than 5 -1 is 4, right? Let me erase 4. Now I'm going to divide by 2. Just eliminate 2 from x. Then I'm going to get -3x less than 2. And my final answer is going to be x belongs from -3 to 2, both parentheses, right? So that's a typical inequality we solved. Now, second type of inequality is going to look opposite direction. What if you have x greater than c? Which means that if you do a number line, and you have like 0 over here, you have somewhere here c, some numbers, and -c. And absolute value of x must be greater than c. Well, when x is positive, it means that it's supposed to sit over here, right? All numbers over here are going to be greater than c. But when x is negative, it's going to lose a sign and again become greater than c, but only for these points, right? Because if we take point between -c and 0, somewhere here, when it loses a sign, it's going to become point over here, and it's not going to be greater than c, it's going to be less than c. How do we solve an inequality like this? We are going to turn it into two inequalities again. I'm going to use the same one, 2x plus 1. Now I'm going to write down greater than 5. Means that the distance from 0 to point x or value of this inequality is greater than 5, like 5 units or greater, for example, like this, okay? That's a solution. What are we going to do with this inequality? We're going to represent it into two inequalities. Well, first, sometimes I click on eraser and I erase what I write. 2x plus 1 is greater than 5. I'm describing this region, the first region. And the second inequality is going to be 2x plus 1 is less than -5. I'm describing this region. Sorry, making arrows. These two inequalities are not going to be solved together like the previous case. They are going to be connected with or. Or means that solution can be either here or here, like we see. It can be either a number over here or a number over here. Not like in the previous one where we had it like together. You solve it like normal linear inequality, and that's 2x, I guess, minus 1 here is going to give me 4, or x is greater than 2. And for this one, 2x minus 1 is going to give me what? Minus 6, minus 1, minus 5, minus 6, and x is less than -3. Now, my suggestion is to graph your intervals on number line and then give interval notation, because here it can be a little bit tricky. So I'm going to graph -3 here and 2 here. So x greater than 2 is going to be over here. X less than -3 is going to be over here. Less is to the left, right? And my final answer is going to be x belongs to intervals. This interval from -infinity to -3 unified to interval to positive infinity, my second interval. And that's how we solve absolute value inequalities. What I want to do, guys, why don't we work on some inequalities by ourselves? I'm going to kind of write down 4 problems on the board, and I'll ask you to stop my video and try to do these problems on your own. And it's supposed to take like maybe 10 minutes, maybe 15 minutes. After that, you come back, turn on my video, and watch correct solutions, okay? So self problems. First problem, x plus 1, x minus 1 squared less or equal than 0. Here, guys, I want you to use interval and test points. Problem number 2, 3x. 3x plus 2 less or equal than 2, inequality with absolute value. Problem number 3, 2 minus 3x greater or equal than 2, also inequality with absolute value. And number 4, a slightly different inequality, which I did not explain, but you can try to guess how to solve it. I'm going to put a little star over here, maybe a little bit challenging. So guys, of course, I'm not going to wait 10 minutes to solve them. I'm going to just kind of count to 5 and start solving them. But while I'm doing this counting, you can stop my video and try to do these problems on your own, okay? And I'm going to count 1, 2, 3, 4, 5, and start working on my inequalities, okay? And you can turn on your videos. Solutions. I'm going to start with inequality number 1, and that's x plus 1, x minus 1 squared less or equal than 0. So I'm going to first find the zeros of my expression. Here is x equals -1, and here is x equals 1, right? They're turning each parenthesis into 0, so I'm going to graph them. -1 here, +1 here, right? Because I have equal sign, I'm going to make them dark. Otherwise, at the end, I'm going to forget about this. And now I'm going to have 3 intervals. Interval number 1, interval number 2, and interval number 3. Well, I'll just need to check these 3 intervals, and that's going to give me my solution. So on interval number 1, I'm going to choose point x equals -2, x equals -2. So what I have, -2 plus 1 minus, -2 minus 1, it's going to be -3, but when we square it, it's going to give me plus. So my total sign is minus. And I'm going to label minus here. My next checkpoint is going to be 0. It belongs to interval -1 and 1. So 0 here is going to give me plus, right? 0 plus 1. 0 here is going to give me -1, but because it's squared, I'm going to get plus again. So here I have plus. And my last checkpoint is going to be x equals, I don't know, I'm going to choose 10. How about 10? You can choose any point over here from 1 to infinity. So 10 plus 1 is something positive, and 10 minus 1 is kind of 9, but when we square it, it's still positive. So positive. Plus and plus is going to give me plus. So I have plus here and plus over here. Now, inequality was asking me to pick up intervals where it's less than 0. Less than 0 means minus. Only interval which satisfies this condition is from negative infinity to minus 1. So I'm going to write down x belongs to the interval from negative infinity to negative 1. And that's my solution. And I'm going to move to my second inequality. My second inequality is absolute value inequality. I want to change to black color. 3x plus 2 less or equals than 2. So what I'm going to do, I'm going to write down this inequality as a double inequality. 3x plus 2 less than 2 and greater than negative 2. And I'm going to put equal sign. Well, operations. I'm going to subtract 2 from all three parts of inequality and get minus 4 less or equals, and here 2 and 2 are going to cancel. And here I'm going to just get 0. 0 is just a number. Minus 2 and 2 are going to give me 0. Now I'm going to divide by 3. Divide by 3. It's going to give me minus 4 over 3. Here x. And 0 divided by 3 is still 0. Very nice. And guys, if you wish to do number line, do number line. But I think we can write down the interval notation. Look at this. So x is supposed to be greater than negative 4 over 3. Over 3 and less than 0. Both points are included. And if you draw interval, it's going to be negative 4 over 3, dark circle, and somewhere here, dark circle 0. And we have all points in between. Okay, I'm going to solve problem 3 over here. For problem 3, what we have? 2 minus 3x greater or equals than 2. We know that this inequality, this type of inequality, when the distance is greater than a certain number, results into two inequalities with two intervals. 2 minus x greater or equals than 2, and 2 minus 3x less or equals than negative 2. I'm going to start solving this one first. So again, I'm going to subtract 2 from all three sides and get like negative 3x here. 2 and 2 cancels, right? And here is going to be what? Just 0, because 2 minus 2 is 0. Now, what I'm going to do, guys, I'm going to divide by negative 3. Negative 3 and negative 3. Well, here I'm going to have what? Just x. 0 over negative 3 is still going to be 0. What should I do as a sign of inequality? I'm going to change it to opposite because a minus. The minus over here. Okay. So I solved the first one. I'm going to do the same with the second one. Again, minus 2 on both sides is going to give me minus 3x here less or equals than negative 4. And then dividing by minus 3 is going to give me, I'm going to write it down, minus 3 here, minus 3 here. So here is going to be x. Here, 4 over 3, right? And minus is going to cancel. And the sign of inequality is going to change to opposite because there was a minus, right? Little explanation why. Well, now here I would suggest you to draw number line. It's just going to be much easier to understand the intervals. So I'm going to start with 0 here and 4 over 3 here. And both of them are dark circles because we do have equal sign, right? And less than 0 is going to be over here to the left of 0, and to the right of 4 over 3 is going to be over here. In interval notation, we are going to have x belongs interval from negative infinity to 0, including 0, united with interval from 4 over 3 to positive infinity. 4 over 3 is included. My square bracket doesn't look like really square bracket included. Okay. And the last inequality, which I labeled with a little star, inequality number 4. How do we solve inequality number 4? X minus 3 divided over x plus 1 greater or equals than 0. Well, this inequality actually is very similar to inequality number 1. Just instead of like multiplication of parentheses, you have like division, right? Well, it's not going to change the method. We are going to still use test intervals. First, we'll need to find zeros of like my expression. The 0 of numerator is x equals 3, and 0 of denominator is x equals -1. Now we are going to draw a number line and label -3 here, -1 here, and 3 here. Now, guys, we do have equal sign, right? So when you substitute 3 here in numerator, you are going to have 3 minus 3, which is going to be 0, and we kind of allowed to have 0 here because it's less or greater or equals than 0. But if you substitute -1 into your inequality, you are going to get -1 plus 1 and 0 in denominator. What should we do with this? We are going to leave this -1 empty because it does not satisfy our inequality, because even like inequality itself is not going to be defined at this point. We cannot divide by 0. Now we're going to investigate 3 intervals we have here. Interval from -infinity to -1, -1 to 3, and 3 to positive infinity. So my test points for interval from -infinity to -1, I'm going to use x equals -2. So what do we have? -2 minus 3 is minus, right? -2 plus 1, well, -2 is kind of, less or to the left from 1. So which means that when we add them, we are still going to get negative number. Minus is going to give us plus. I'm going to put plus over here. Now, from -1 to 3, we can check number 0, right? 0 is from -1 to 3. So we plug it in and we have minus in numerator because it's like -3, and plus in denominator because it's plus. So total is minus. I'm going to put minus here. And the last one is going to be any point from 3 to infinity. Well, I'm just going to choose a point like 4. So 4 minus 3 is positive number. And 4 plus 1 is also positive number. So we have plus. And I'm going to label it as plus. Now we'll need to look back at our inequality and see like which part of this number line we'll need, positive part or negative. Looks like we need the part where this expression is greater than 0. Well, greater than 0 is from -infinity to -1, not including -1, and from 3 to positive infinity, and we'll need to include 3. Sorry, I put parentheses. Let me raise it 3 too. We're going to write down x belongs, and that's our final interval notation. I'm going to shade this because it works for us, and shade this. And again, if you have an opposite direction of inequality sign here, you will choose this interval. So the sign of interval is just a sign of interval. You will need to decide, looking back at inequality, which is going to be good and which is going to be bad. It's not always like pluses are going to work. Okay, I think we are done with inequalities, and I kind of suggest you to practice some homework problems. If you have any questions, let me know. And that's going to be it for this lecture. Okay. Thank you everyone for attending.